I'm Anil Kumar, and here we have 4 interesting questions on exponential equations. I'd like you to pause the video, copy these questions, solve, and then check with my solution. The first one is 2 to the power of 2x minus 4 equals to 0. Then we have 10 times 3 to the power of x equals to 270. 2 to the power of x times 4 to the power of x times 8 to the power of x equals to 16 times 16 to the power of 3x minus 9. And the last one is 27 to the power of 5x equals to 3 times 9 to the power of 3x. Now let's begin. The very first one is 2 to the power of something is 0. So let me know, what could that be? Do we really have a solution? Well, here we do not have any solution. We'll write no solution. Can you tell me why? Well, exponential functions approach 0, but they are never 0, right? So remember that exponential functions approach. They can be very, very close to 0, but they're never 0, right? Approach 0 only, right? They cannot be 0, correct? There is nothing which will give us 0 as the answer. Next one is 10 times 3 to the power of x equals to 270. All are different kinds of questions, and therefore I think this is an excellent exercise. To solve this, we can divide by 10 first, so we get 3 to the power of x equals to 27. And now we can write 27 as power of 3. Now 27 is 3 to the power of 3, right? 3 times 3 is 9, 9 times 3 is 27. And therefore, since they have same base now, we can write x is equals to 3. So that is how we can solve this one. Now here we have a very interesting question, 2 to the power of x, 4, 8 and all those things. Now we should have a common base, correct? Best common base is base 2, the minimum of these two. So let us write each one of them as base of 2. So the first one is already there for us, so we could say it is 2 to the power of x. The next one is 4 to the power of x, which is 2 to 2 square, right? So we can write 2 to the power of 2x. Now 8 is what? 8 is 2 cube. So that could be written as 2 to the power of 3x. Do you see that? Oh, sorry, 3x, right? And now what is 16? 16 is 2 to the power of 4, right? And we already have some exponent which gets multiplied, which is 3x minus 9, correct? Now we can apply the laws of exponents. When you multiply, these exponents get added up. So we get x plus 2x plus 3x equals to the exponent of the number on the right, which is 4 times 3x minus 9, right? Now you have a linear equation in x which can be solved. 1 plus 2 is 3, 3 plus 3 is 6. So we have 6x equals to 4 times 3 is 12, 12x minus 36. Now we can bring 36 on the left side, and we have 6x, and therefore x is equals to 36 divided by 6, which is 6. So we get our answer, which is x equals to 6. So for this, the solution is x equals to 6. Correct? Okay, let's solve the last one now. The last one here is, let me just make lines here so that we can clearly see what the questions are. So the strategy is, write them as powers of 3, right? 27 is 3, right? 3 to the power of 3 is 27, so we can add 3 to the power of 3, and then that gets multiplied by 5x, correct? In this case, we have 3, and 9 could be written as 3 square, right? So we have 3 times 3 square, that means 2 times 3x, let me write 6x here, correct? Now, if I have 3 times something, well, we'll do one more step, 15x, multiplying 3 with 5x. Here, they are multiplied, so it gets added up. 3x, 6x plus 1, correct? So that's kind of tricky. You might just get this one wrong. Now, here we can solve for equate the exponents, which is 15x equals to 6x plus 1, and we'll solve them by bringing 6 on this side. So 15x minus 6x is, okay, so 15x minus 6x is 9x equals to 1. Let me just move this page a bit. So we have x equals to 1 over 9 as our solution, right? So let me write down this solution here. Here we get answer as x equals to 1 over 9. So that is how we can solve these questions. Have a good look at it. Try to understand how we did it. I hope it helps you. Thank you and all the best.